Hello, everyone, and thank you for joining our session. I am Serge from VertexCom. I'm an account manager, and I am here to introduce our chipsets for EV charging communications with support for features such as plug and charge and vehicle to grid. So first, a few words about our company. What is VertexCom and what do we do? We are a mesh network innovator for long-range, large-scale IoT. We specialize in the design of sub-gigahertz radio frequency, power line, and hybrid chips and networking software. All of our products support open standards, such as IPv6, and also offer certification, interoperability, and enterprise-grade security. We also pride ourselves in supporting proven industry technologies, such as combined charging system, or CCS. Our team is highly experienced and comes from leading companies in the semiconductor industry, including MediaTek, Trendchip, Trident Micro, and Qualcomm. Thanks to the expertise of our R&D team, after years of operation, we now have a strong success record in RF, analog, wired, and wireless IC design, and more than 25 core patents. Now, if I were to summarize what we do in one sentence, or even just one word, I would say that we optimize. Our goal in every project is to deliver a solution that will enable our clients to build IoT products, making user experience as smooth, as reliable, and as secure as possible, no matter the scenario. And our target markets include smart energy, mostly here electricity metering, smart house, smart sensor, and smart city. This last category includes, for example, EV charging communications, but also solar panels, smart city lights, smart offices, and so on. Now, this slide shows an overview of our current product lines, from Wi-SUN for wireless communication between smart meters and other applications, to HomePlug GreenPHY for EV charging communications, and also some other technologies, both PLC and hybrid. But let's move on to the focus of today's presentation, our chipsets for EV charging communications. First of all, they are compliant with HomePlug GreenPHY, which forms the basis of the EV charging protocol ISO 15118-3, which is used in the CCS standard. CCS is implemented by nearly all leading electric car makers in Europe and the US. And also, as revealed by the title of this presentation, our chipsets support features such as plug and charge and ISO 15118-20, bidirectional power transfer, or BPT. Now, for your reference, this picture shows an overview of the ISO 15118 protocol family. So our HomePlug GreenPHY solution covers ISO 15118-3, so basically the bottom communication layers, which means that we provide the hardware and basic software and reference design for the physical and data link layer requirements, but the higher layers have to be developed by the client. And why is it important that our solution supports ISO 15118? Well, support for ISO 15118 is crucial not only because it's an industry-leading standard, but also because of policies. For example, the National Electric Vehicle Infrastructure Program in the US, or NEVI. It has made it a requirement, a prerequisite for companies seeking to tap into federal funding to support ISO 15118. And 15118 is a driving force for the adoption of such features as plug and charge, and also for industry-wide interoperability of chargers from different manufacturers. So what solutions do we currently have? Right now in our offer, there are two different HomePlug GreenPHY chipsets for EV charging communications. The first of them, MSE1021 plus MSE-X24i, or also called SECC chip, supports charging stations. The other one, MSE 1022 plus MSE X25i, or the EVCC chip, has been designed for use in electric vehicles. Now, the main difference between the chips is in the qualification. So, simply speaking, the solution for automotive use has to meet a more stringent set of requirements. Therefore, it supports AEC Q100 Grade 2 and also a SPICE requirements. And the SECC chip only needs to meet industrial grade qualification. Now, apart from the two chipsets for EV charging communications, we also offer a sniffer. So this is a diagnostic tool for ISO 15118 communications over power line. Now, some words about the advantages of our solution. So based on our tests and experience, we know that our chipsets pass the interoperability with solutions for both charging stations and vehicles, which means that, for example, if a charger uses our solution, but an electric vehicle uses our competitor's solution, they will still have no problem whatsoever communicating. And our chips have also been successfully used in the field by manufacturers across Europe, Asia, and America. In particular here, I want to share that Vector, which is Europe's #1 vehicle testing company, has been using our solution in their test equipment and at Charring Plagfest. This is an overview of our solution's features versus other market existing solutions. So first of all, in our case, technical support comes from a strong and experienced R&D team directly. There is no need to go to any third party to obtain support. Second, the power consumption of our chipsets is lower than in the competitor's case. We also use different interfaces. So we support RMII and SPI instead of SPI and UART. And our chipset can support IEC 61851 PWM generation, which typically isn't possible with other chips. And you can use the sniffer, the diagnostic tool that I mentioned, specifically in our solution to calibrate PSD. Now, these are the different interfaces used by our solution. So as I mentioned, SPI, RMII, and also particularly in our solution for the charging station side, also Ethernet. So this is an example, a diagram of how you can build a network, let's say, of charging stations communicating through Ethernet, through a switch, and then to an external server. Apart from the chipsets themselves, we also provide our clients with sample C code and sample C driver to assist them in development and testing. And we also offer evaluation boards. So this is a diagram of our HomePlug GreenPHY evaluation board. And as you can see, it uses our chipset and also an XP's LPC 1758 MCU. And here you can see a picture of it. So as you can see clearly from this picture and also from the diagram on the previous page, our solution is a two-chip solution, which means that you have the main chip and also a separate line driver on it. Now, a few words about our sniffer. Basically, in simple terms, what it does is it listens to all power line layer 2 traffic for system verification, monitoring, and debugging. Now, it can monitor the IEC 61851 control pilot, and also specifically in our chipset, it can be used to calibrate the PSD. We've also developed our own customized Wireshark tool, which our clients can use to get information from ISO 15118 messages. And as you can see on the right, our sniffer is quite small, so it's perfect for use in a garage or car for on-road testing or debugging. Now, this is an example of what kind of information you can get using our sniffer. a screenshot from Wireshark. So for example, you can get Slack parameter exchange, signal strength measurement, logical network parameter exchange, and also all the information specific to messages, so all the message content. Now, I also have some news from the market that I would like to share with you. So first of all, we've partnered with Vector for their development of VH5110A, which they also call CCS listener. It can analyze communication between a charging station and an EV based on CCS protocols. And apart from that, it also listens to power line communication and can convert it to Ethernet packets for display and analysis in Canali, which is Vector's own analytic software. Now, moving on to the features that our chipsets can support. First, what is plug and charge? Plug and charge is outlined by ISO 15118, road vehicles, vehicle-to-grid communication interface. So this is the same family of standards or family of protocols that I introduced to you before. This feature relies on a combination of encryption algorithms and digital certificates, which are assigned to different roles within the plug and charge ecosystem. And although I won't get into detail here on how it works, basically the plug and charge ecosystem ensures a secure exchange of information between cars and charging stations without any need for external verification with apps, credit card information, and so on. Now, why support it? Why is it important for example, EVSE manufacturers to provide this feature? Well, simply speaking, it ensures a seamless charging experience. So with support for the plug and charge feature, our chipsets enable charging stations and cars to create a smooth experience for the drivers, because they can simply connect an ISO 15118 compliant vehicle to also a compatible charging station, and the two sides will automatically establish a secure communication channel to exchange critical information. It's simply a better user experience. Now, continuing, our HomePlug GreenPHY chipsets also support the implementation of ISO 15118-20 BPT. BPT stands for bidirectional power transfer, and it's a feature also known as V2G, vehicle-to-grid, or simply bidirectional charging. Actually, maybe to expand the context a bit, you could say that V2G is part of V2X. V2X stands for vehicle-to-everything, and it simply means that the EVs can not only draw power from the grid, as in the case of regular charging, but also contribute back, powering up the grid, so that's V2G, homes, V2H, or personal electronic devices, or anything else that needs to be powered up. It also allows the drivers to optimize charging schedules, saving costs during peak times, and benefiting the grid while meeting their mobility needs. And in my opinion, V2G has a large potential to enhance our energy resilience at a time of a global shift toward renewable resources. And it can also help us reduce emissions, as the drivers may use their EVs as clean energy storage. Now, CCS combined with ISO 15118-20 is a future-proof way to integrate EVs with the grid. And why? With the CCS standard, bidirectional access to EV or its battery occurs directly through the charging station. So there is no need for extra V2G hardware in the vehicle. CCS-enabled wall boxes facilitate versatile charging options. So it's suitable for both home charging and also high power infrastructure in public spaces, which ensures that using ISO 15118-20 and CCS, we have a future-proof compatibility in the evolving energy landscape. Now, another piece of news that I would like to share is that one of our partners, Advantix, which specializes in electric power conversion and EV charging applications, has already developed a functioning implementation of ISO 15118-20. And the updated CCS software enables DC charging and discharging of an EV. And it has already been successfully tested against several other participants at Charging Festival Europe in Poland last year. And lastly, I would like to share some recent news about where V2G might soon be headed. So in California, Senate Bill 233 aims to mandate V2G in the entire state. And the bill hasn't been passed yet. It's still under discussion and voting, last I checked anyway. But if passed, it would require all EVs sold in California to be bidirectional capable in 2030. And it's speculation, of course, but it may encourage other states and countries to follow suit. It may just set a precedent for how V2G can be legislated and adopted on a large scale. And this is all for now. So thank you very much for listening to our presentation. I hope you've learned some new interesting things, and I also hope to hear from you. You can contact us using our email or read more about us and also other projects we're supporting on our website. Thank you.